How can you really know that this boy is getting closer? How can you tell if an object is further than another? A young man from the small town of Vinci really opened the eyes of many with his use of perspective.
Leonardo da Vinci. It's been a while. Well, since I heard that name. Leonardo da Vinci was born April 15th, 1452. At the age of 14, he was apprenticed to a man named Andrea di Cione. In the early years of his adulthood, he received an education in Latin, geometry, and mathematics.
While working as an apprentice, Da Vinci was exposed to a wide variety of skills, many of which he mastered very quickly.
But the fascinating thing is, he was a painter, an architect, an inventor.
He was a man, a truly great man.
Painting is often regarded as Da Vinci's most impressive skill.
But you see, the thing is, in many of his paintings, Leonardo often incorporated mathematics of some sort.
One of the most important formulas that Da Vinci used in his paintings was the Albertian formula, discovered by a man named Leon Battista Alberti. Now, Michael Hunt is here to describe it for us. Mike?
Thanks, Paul. As you can see here, the Albertian formula can easily be explained through this diagram. Point C here is the vanishing point. Then a line is drawn in a perpendicular fashion down, meeting line segment AB. Next, line segments are drawn from A to C and B to C. After, at even intervals between A and B, lines are drawn going diagonally and converging at C. There is a line segment from point N to point C, which is parallel to segment AB. This line, NC, is supposed to be the horizon. The distance from point N to point R is considered the viewing distance, where R is the right diagonal vanishing point. Lines are drawn at decreasing intervals parallel to line segment AB. At the intervals drawn for the first diagonal lines are drawn going out and converging at R. This, in turn, creates a feeling of perspective where CR is the viewing distance rather than the actual NR. As you can tell, it looks like R is further back in the drawing than A, B, and C, when actually it's the same distance. A diagram. A truly great diagram.
The golden ratio creates what is thought to be the ideal size rectangle on which to create art. Now, painters from the Renaissance to today have found that this size of canvas for their art looks very pleasing to the eye. The golden ratio is approximately 1.618033988. It is reached by using the algebraic formula a plus b over a equals a over b equals phi, or the numerical formula phi equals 1 plus square root of 5 over 2 equal to 1.618033988. It can be explained as a plus b is to a and a is to b.
A formula. A truly great formula.
As you can clearly see in this painting, Da Vinci used the golden ratio to form the rectangles in the Last Supper scene. These rectangles form ideal spacing that is much more pleasing to the eye.
Another formula that was really similar to the Albertian formula that Da Vinci used was the linear perspective formula. You must draw a horizontal line and then orthogonal lines diagonally coming at a point towards the horizontal line. This will create the vanishing point, and yeah.
Since Da Vinci was both a master of art and math, he would not stand for having his paintings be anything but the best. People still go to the Louvre Museum today to marvel at his most famous painting, the Mona Lisa. Da Vinci's works in math and art have influenced millions of artists and mathematicians today.
The most praiseworthy form of painting is the one that most resembles what it imitates.